Good morning, year three. I hope you're well and have had a good day. Today, in our maths recap lesson, we're thinking a bit more about bar models. So, I know we talked about division as a school skill to, as a type of question to resolve with bar models earlier in the week. We're going to look at a couple of other examples of that today, and then I'm going to ask you to just go and set yourself some division problems that you can then draw the bars that will help you solve. Because the more practice you get at doing division bar modeling and using bar models yourself, the more they'll just become like that riding a bike, like that swimming, like that breathing that you do without thinking about it, and then they'll be a really useful tool for you. Okay, today then we're going to be successful by thinking about the factors of 3, 4, and 5. The factors which go with various multiples. So we're going to see if we can unpick, well, we've got a product. What would the factors be that go with those multiples of 3, 4, and 5? How can bar models help us? So we'll look at how they can help us to solve some problems and to think about them in our brains. And then we're going to solve some problems that are linked to those concepts. Okay, guys, so what I've done here is I've cut up our 4, 3, and 5 times tables, and you can see one of the products for each one is either 3, 4, or 5. Sorry, one of the factors. So you can see in the first column we've got 3s, second column 4s, third column we've got 5s. Okay, and over on this first column on the left-hand side, my first product is 3. So how many lots of 3 make a product of 3? What factor for my second one goes with 3 to make a product of 12? What factor goes with 3 to make a product of 18? And what factor goes with 3 to make a product of 24? For our second column, what factor goes with 4 to make a product of 8? What factor goes with 4 to make a product of 20? What factor goes with 4 to make a product of 12? And what factor goes with 4 to make a product of 36? For our final column, what factor goes with 5 to make a product of 20? What factor goes with 5 to make a product of 35? And finally, what factor goes with 5 to make a product of 45? Okay, so what do we think? First column, how many lots of 3? What I'd like you to do actually, guys, with these, sorry, there's one extra in the final column now. How many lots of 5 make a product of 0? With each of these, guys, can you now write down the missing factors? So which factors are covered by the first blue strip, the second one, and the third one? Pause your video while you do that, please. And then back in 5, in 4, in 3, in 2, in 1. One lot of 3 makes 3. 4 lots of 3 make 12. 6 lots of 3 make 18. And 8 lots of 3 make 24. 2 lots of 4 make 8. 5 lots of 4 make 20. 3 lots of 4 make 12. And 9 lots of 4 make 36. 0 is the factor which goes with 5 to make a product of 0. 4 lots of 5 make 20. 7 times 5 is 35. And 9 times 5 is 45. Okie dokie, guys. Now, bar modeling then. It's really useful if you're a bit stuck. So even if you've got just a number problem, there's no words attached to it. Sometimes we're a bit stuck and we're like, I don't know what to do. I don't know what to do. I'm a bit scuppered. I don't know what to do. And sometimes it's because numbers are a bit tricky to us. So I know some people, my son included, they get their numbers a bit twisted up. And even if they could do it, if it was a picture, they can't do it with numbers sometimes. So sometimes using a picture, a drawing, helps us to understand it. And sometimes it might be that it's hidden within words. Here, though, 36 divided by 4, if I'm not sure quite what I'm being asked to do, what I can do is I can draw it. And I could draw it like this. And I prefer it if you use a ruler and pencil. But if I was to do it freehand, it might look like this, where I've got my bar, my hole is 36. And I know I'm splitting it into 4 equal sections. And each one of those question marks is an equal section. They're supposed to be anyway, because they're a bit rough and ready. They're not drawn perfectly. But that doesn't matter. It's about what it means to me. I now know that I've got 4 equal parts that are the same when they're added together as 36. And that picture helps me understand that a little bit. So if by accident I put my answer as 40, I'd know that couldn't be right because 40 is not bigger. 40 is bigger than 36. So it wouldn't make sense that one of my question marks was 40 because then I'd need 40, 40, 40, and 40. Then I'd have 160. So by having this picture, it helps me understand a little bit more about what to do. What do you think should go in there? You managed to work it out? Those question marks? It's 9, shouldn't it? Because 9 add 9 makes 18. 9 plus 18 makes 27. Plus 9 makes 36. Or, because you're all great at TT Rockstars, you know that 4 times 9 is 36. We've got another question here. So we've got 25 divided by 5. If we have that, it's synonymous, it's linked to, it's the opposite of what factor goes with 5 to make 25. Those two are linked, and it's really useful to know that they're linked, because then we can think about what we can work out. Now we know here that we've got a whole of 25. And rather than split it into 5 equal groups, as we sometimes do with the earlier one, where we split that into 4 equal groups, we know that each of these groups is made up of 5. And now we're going to work out how many groups are we going to have. So we've divided it into chunks of 5. So divided it into 5. But how many chunks are we going to have? How many lots of 5? Well, that knowledge about my 5 times table, and this is why doing your times table rockstar is so useful, will tell me that each one of those could be what? 5 add 5 is 10. Add 5 is 15. So I now know that 3 times 5 is 15. But I also know that 5 more than that is 20, and 4 times 5 is 20. So 5 times 5 is 25. So it's 5 lots of 5, isn't it? So each one of those, so there should be 5 blocks at the bottom, shouldn't there? So because 25 divided by 5 is 5. Right, one of your questions from your work on money was actually something that you could solve with a bar model. I'm going to try and show it. It gets a bit fancy, this, so don't worry too much. Just to explain that if you weren't sure what you were being asked to do, a bar model could help. You knew that the total cost was 63. Your bar was 63, wasn't it? And you knew a toaster with half as much cost as a kettle. So a kettle was double the cost of a toaster. And that meant, didn't it, that a yellow section and the brown section together made the blue section, basically. So the kettle, which is the brown section, and the yellow toaster combined to make the blue £63. So that's the bar making things make sense to me. And because I know that a kettle is twice as much as a toaster, I actually know that rather than it being one toaster and the cost of one kettle, it's almost like the cost of 3 toasters. Now I've got to work out what 63 divided by 3 is, because I want to work out what a toaster costs. Now 63 divided by 3 I can work out is £21. I know that 3 divided by 3 is 1, and 60 divided by 3 is 20. Now if I've got £21 for each of those, then I want 2 of those sections for a kettle, and therefore it's 21 multiplied by 2, which would be 42 because of kettle. Now, it might feel a little bit much there, but a complicated problem can make more sense by going through these bar model steps. More examples here. So we've looked at 36 divided by 4 earlier, so hopefully you'll be able to spot what should be in our red sections. 45 then. How many sections am I dividing 45 into? 45 divided by what? And then I've got 84 shared between 3, and I therefore do 84, and I put 3 blocks underneath to help me understand what I'm being asked to do. For 36 then, I can see it's 9, because I know that 9 times 4 is 36. For 45, how many lots of 5 do I need to make that? Well, 5 times 8 is 40. So 5 times 9 is 45. So therefore it's going to be 9, isn't it? Now, I don't know which times table goes for 3 times something to make 84. I know that 8 is not going to be 20, because 3 times 20 is 60. So it's going to be bigger than that. But I also know that 3 times 30 is 90. I know that 3 times 3 is 9. So 3 times 30 is 90. So I know it's between 20 and 30. Now, my product, 84, ends in a 4. What multiplied by 3 makes a product of 4? 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 20. 3 times 8 is 24. So it might be 28. It is, because 60 plus 24 is 84. So it's 28. Okay. Now, what I'd like you to do is set yourself some divisions. You know the whole, which is where our question mark is here, and you have to figure out how much is in each group. So here I would be divided by 3 on this one. But can you draw yourself some where you try and get some quite big numbers? See if you can do a 3-digit number. Get some big numbers and divide them into different sections. So maybe divide them into 4, 5, 6. Could you even try some 7s? Could you split your whole into 7 equal parts and really stretch yourself with those times tables? Give yourself a go doing that. It's just a bit of practice. Send them in to Miss Ashford and Mrs. Hand if you can, but don't worry too much about those. As well as that, guys, we're going to be looking at your pictogram work today. It's all about visual representation again. Just a reminder with the pictogram work, make sure that when you draw them, the indications for that piece of fruit or whatever you're representing, they have to stay the same size, otherwise it doesn't work as a way of representing that data. You're going to have some answer sheets today for your tally chart work, also your end of block assessment. So please have a look at those with whoever looks at your answers, just to see how you're getting on. Thank you very much for your listening, guys. See you soon. Bye-bye.